What we're doing today is graphing some two-dimensional inequalities. The cool thing is it's the same idea as before where this was an equal sign, except he's not an equal sign anymore. He is an inequality, be it a greater than, less than, greater than or equal to, or less than or equal to. Got a question. Is it in the format of y equals mx plus b, except it's not an equal sign, it's an inequality? Yes or no? Yeah. What's the slope? 1/3. What's the y-intercept? 5. But follow my lead. Let's start with this. Don't work faster than me. Let's start at 5 on the y-axis, right? That is the y-intercept. And then since this is on paper, we will rise and run with our slope, which is rise 1, run 3. So we'll rise 1, run 3. And we'll try to do that 4 times if possible. Rise 1, run 3. Rise 1, run 3. You could also go down 1 to the left 3, down 1 to the left 3. But here's the trick, right? If this was an equation, we would connect those together with our straight edge, nice and solid. This is not an equation. This is an inequality. I have one question for you about this symbol. If you were doing it on a number line, would you put an open dot or a closed dot? That is an open dot scenario because it doesn't have the little equal to bar with me on your right. That means that that point on the number line didn't count. It didn't work. Like x had to be greater than 3, so 3 didn't count, you know. This line doesn't count. So to draw that mathematically, you have to make that a dashed line instead of a solid line. So please make it a dashed line. That's the same thing as like an open dot. It is not a solid line. But that's still not it. We got to shade where the solutions to this are. And there is a secret. The secret is y has to be all by itself for this to be. What does that symbol say? Greater than or less than? Greater than. Do this. Put your pencil on the y-intercept. Right here. And if I say greater than, what does that mean to you? Go above or below that dot? Above. Lightly, with a pencil, shade this in. Just lightly shade that in. And I'm going to take some time on these first couple because this is a weird concept. What did we just shade? Where all the possible solutions are. There's an infinite number of answers to this. So I'm going to just put this ordered pair right here. You don't need to draw any of this, but right here, do you feel that point is at 1, 6? Are you with me right there? That's at 1, 6. Is he in the shaded zone? That means he's going to be a solution to this system. It's not a system, but inequality. That means if I put 1 in for x and 6 in for y, I would say 6 greater than 1/3 times 1 plus 5. Well, 1/3 times 1 is 1/3. Is 6 greater than 5 and 1/3? Yes or no? That's a true statement. Would this ordered pair satisfy this inequality? Yes or no? Is he in the shaded region? Yep. Would this ordered pair satisfy that inequality? Yes. Would this ordered pair satisfy that? Nope. This one? Nope. This one? Although there are an infinite number of correct answers, there's also an infinite number of incorrect answers. Here's the trick. What about this one right here? Would it satisfy? Where is that? On the line. Does it work or not work? Let me try. Count or not count? Does not count because there's no equal to bar on it. Cool? So let's try again. Oh, by the way, what kind of line was that? Horizontal, vertical, or oblique? Oblique. It had 2 letters. Let's try this one. Let's do it before we start. Will it be horizontal, vertical, or oblique? It'll be oblique if it's got both x and y. Horizontal, vertical, or oblique? Oblique is y all by itself. Yep. So let's do a -5 for our y-intercept. Bada boom. And then the slope is -4/5, so down 4 to the right 5. I can't do that again. I'm out of space. I can't go down 4 to the right 5. So how about going up 4 and to the left 5? And then up 4 and to the left 5. 1, 2, 3, 4. And then here's the question that you got to ask yourself. What kind of line? Does that have an equal to bar or not? Yes. It's like open dot, closed dot. Isn't this a closed dot scenario? It's a solid line. It is your normal solid line like you're used to. But what makes this different is we have to shade where all of the solutions are at. How do you do that? Here's our rule. We're going to make sure y is all by itself. Is y all by itself when we started? So then you read the symbol. The symbol is a less than. If you just put your pencil on the y-intercept, Less than means go below that, so I will shade down here. I'm not asking you to like waste a lot of pencil, just to make sure I can see how you shade it. Please don't let me forget to show you how to do that on the computer as soon as we're done with this worksheet also. It's like, how do you do that on the computer? You know, so we'll do that. Rock on. Okay, next guy. How many letters does this guy have with it? Does it have both X and Y, or does it have only an X, or does it have only a Y? How many letters? Both. That's going to be oblique. This is supposed to be the easiest oblique line to graph ever. It is, for some reason, the most optical illusion-y hardest one. Is Y all by itself on one side of the symbol? What is the number in front of X? And then what is the y-intercept? 0, right? So we will start at 0, and then we will rise 1, run 1, rise 1, run 1, rise 1, run 1. It is time to connect the dots with a line, solid or dashed, maybe. Dashed, because there is no equal to bar. Dashed, because there is no equal to bar. Then put your pencil on the y-intercept, and that symbol is a greater than. That means shade above. Shade above that line. The steeper the line gets, the harder it is to figure out where above is. I'm going to go back and just show you, just for fun, since I was thinking about it right now. Where the heck is above that line? You know, like the steeper that it gets, the harder it is to see where above it is. If you put your pencil on the y-intercept and go above that, that's where above that line is. And people are like, that looks like it's to the left of it. Well, it sure does, but it is also above it. So trust me on pencil on the y-intercept, above or below will get you where you need to go. Sound cool? All right, how about this guy right here? How many letters? Just one. But even though it's only got one, they still want us to graph it two-dimensionally because we got an x-axis and a y-axis, 2 dimensions. Horizontal, vertical, or oblique. What kind of line will that be? Horizontal. What kind of horizontal line? Solid or dashed? So I'm going to go to 4 on the y-axis and then just draw myself a horizontal line. It's even hard to see it on that one, but a horizontal line. And of course, he's got to be dashed because there is no equal to bar. We're still reading the symbol to see where to shade. Y is all by itself on the left, by the way. So that is a less than, so that means we shall shade below it. Like I said, don't waste a lot of pencil. Just let me know that there's some shade there. Throwing lots of shade today. Are we okay with this so far? Pretty basic concept. What kind of line will be on 5? Horizontal, vertical, or oblique? That's vertical. It's only got x's. Will it be solid or dashed, though, also? Yep. And it's been a while since we graphed vertical lines. You don't even have y-intercepts most of the time. The only time is if it would like x equals 0. But this is x equals -2. Go to -2 on the x-axis. Go to -2 on the x-axis and draw a vertical line through that. And he would be solid in this case. He would be solid. This is one of the small scenarios where my above and below situation doesn't work. Like you can't be above or below a vertical line. But you can be to the left or to the right of it. Where do you think less than means? To the left or to the right? To the left. And just to hammer a point home, because we are smart, doesn't it mean all the x's have to be less than or equal to -2? If I get rid of the shading, is this x value less than -2? Is this x value? All of these x values, I don't care where the y's are at, all of those x values are less than -2. Cool? So those were our nice, easy little ones, because we didn't have to like get y by itself at all, or whatever. On this one, isn't it oblique? Aren't there x's and y's? And of course, I did show you how to graph this with x and y intercepts. It's harder. It's going to be harder to graph the inequalities. Let's get y by itself is the move. What's the first thing you need to do to get y by itself? Subtract that 3x over, right? Subtract that 3x over. So I will do that. 2y is right here. Should the symbol switch if I subtract 3x? Nope. Please put it first and then the +6 last. You see how we're going y, symbol, mx plus b, right? So cool. Y is not all by itself. There is a times 2. should I get rid of it by dividing by 2, of course, right? But should I switch the symbol? Nope. If you need to be a baby stepper, keep doing it, man. Like all 3 spots get divided by 2. X off to the side, and a +3. I can care less if you don't show the baby steps. I would say if you put the baby steps, sign errors happen less often, right? You know, so I divided everything by 2. Now, why did I like that one? Because I know the slope and I know the y-intercept right now. What is our slope? Excuse me, what is our y-intercept? 3, ba-ba-ba-boom. And then we will go down 3 to the right 2, down 3 to the right 2, down 3 to the right 2. And the number one messed up thing about these is what kind of line, solid or dashed. It is such an easy thing to brain fart, you know, but it happens. See if you can shade it in the right spot. Put your pencil on the y-intercept, and you have to read the one where y is all by itself. Reading the guys up there doesn't work every time. If you get y by itself, this trick works. That is a greater than, so that should be above this dude. Yeah. Pretty simple. Like I said, I promised you a pretty easy day today, right? Can you realize this is going to be oblique? Yes, because it's got x's and y's. Please get y all by itself, and then stop before we graph. Pause the video, get that done. So I subtract the 5x over. Sometimes we forget that that is not a 2y, that is a minus 2y. You with me on that? There's a minus in front of it. When I divide by -2, should the symbol switch? Yes. Sorry, I'll show this baby step. And everybody knows it. We should get better at it. What is a negative divided by a negative? So that is 5/2 x minus 5. All good with that? Graph him. And what kind of line will it be? Solid or dashed? Solid. And check your shade. Check the shade. Go to the y-intercept. It is a greater than, so that is above. Is there one more of these? Please pause the video and get that next number 8 done. Yes. Yep, negative over negative positive, and then we got this should be a -5, right? Are we okay? Yeah, signs get us. That's why showing the baby steps helps a lot of people. They see the little things, right? So I added 4x over to the other side. The symbol did not switch. Then I divided every term by 5. So I'll show that for you right here. And the symbol does not switch. I need a dashed line for that, right? And then the only time this trick works, this above and below thing, is y's got to be by itself. Also x, you know, but it's like the letter has to be all by itself. That's a greater than, so that is above that line. Cool. I'll bet you could have figured out how to do this on the computer without me, but I'm going to show you anyway. So here's one from homework. It's going to be oblique, right? It's already got y by itself. Here's what you have to pick first, my friends. I'm going to clear everything because there's a dot on there for some reason. You have to pick what kind of line you want. What kind of line, solid or dashed? Dashed. So do you see the two options down here? There is a solid line and a dashed line. Don't worry that it's always shaded above this. It doesn't matter. It's just showing you it's going to shade for you as well, right? So I will select the dashed line. Then I have to start by plotting my y-intercept of -5, so boom. And then I will go down 3, 1, 2, 3, to the right 4, 1, 2, 3, 4. That's all you need is those, but then you move your pencil on either side to see where the shade is supposed to be. This shade is supposed to be less than, so wouldn't that be, if you put your pencil right there, go below, down there, and click somewhere. And then it'll say you're good. Cool? So select the type of line, solid or dashed, plot your points, then put your shade where it needs to go. Cool? All right. So on the last few, you see they have already got the graph. They ask us to write the inequality. What is missed the most is the inequality. We get the slope and the y-intercept right. We forget about the inequality. So we're going to start with y because he's oblique. What kind of line is it? Solid or dashed? Solid. And where is it shaded? Above the y-intercept or below the y-intercept? So that would be a greater than or equal to. Are you with me on that? Because it's shaded above, and it was a solid line. Then you got to count the slope. So I'll sit here, and I'll start here at -4. And then what's hard about it is you just got to go find another nice, neat spot where it's like, okay, it landed on a grid, you know, like right where the grids intersect. So rise 1, 2, run 1. Are you okay with a slope of 2 over 1, which I would call 2? If you had 4 over 2, well, you can do that also. You got to reduce it to 2 over 1. Are you okay with that? What needs to go next to it, though? That's missed a lot. What needs to go next to it? X, and then -4. All right, so let's try that on the next one. It's going to have a y. It's shaded below. If you just go to the y-intercept and see where it's shaded, above that dot or below that dot, that'll help you. So that's going to be below. Equal to bar or not? Nope. And then I need a slope. Man, you could go all the way down to this one if you want to. It doesn't matter which one you go to, as long as you count rise over run and you reduce. So I would go down 6 to the right 3. Down 6 to the right 3, doesn't that reduce to -2 over 1? Right? So wherever you can find to count from one spot to the next, it's cool. Just make sure you reduce it. X plus 6, is that what it was? Plus 6? You cool with those? Right? Pretty basic. And then the last thing, because we did some absolute value stuff last time, I like to throw these in. They're like, when would you ever see absolute value inequalities? See them all the time, right? You see them all the time. Like when there is a tolerance involved. For example, like in a hospital, this is 100% fact. I don't know how much you've been in a hospital. They don't let you turn the temperature of the room to anything you want. It's like mandated laws in the hospital that the temperature room must be within 3 degrees of 72 degrees Fahrenheit, right? So you talk to me in English, right? If it's got to be within 3 degrees of 72 degrees Fahrenheit, what's the hottest it could possibly be in that room? 75? What's the coldest it could possibly be? Do you see, like, it's mental math basically, right? But mathematically, we can write an absolute value inequality to make that make sense. So right here, which one of these is the tolerance? Is 72 the tolerance, or is 3 degrees the tolerance? Like, tolerance means we're tolerating, we're allowing it, right? Which one's the tolerance? 3. Some people like to put a T above that when they're doing homework. They're like, there's the tolerance. And I have given you the equation that we're going to follow. All of these tolerance scenarios will always be this. The absolute value of x, x is just the allowed temperature, minus your tolerance, in this case that is 3, less than or equal to some sort of stated value. Would you believe that the hospital has put in place that they have stated it must be 72 degrees, right? You know, it's got to be 72 degrees. So I'm going to make up a couple temperatures. This is x, right? What if it was 74 degrees in that statement? Would that work? Pause. Well, I might have this formula backwards. Yeah, we got this formula backwards. Because it should be. No, that would work. That would work. Sorry, I had a brain fart right there. That happens to the best of us some days. I'm definitely not the best of us, but still. Would